Hi, this is Alfawzia Nihar from At Home Tuition. Welcome to our session today. The topic that we're going to discuss in our today's video is solving quadratic inequalities. In this video, we will be looking at solving quadratic inequalities using two different methods. The first method is solving a quadratic inequality using a sign graph of factors. And the second method that we are going to discuss is solving quadratic inequalities using the test point method. Okay, we can discuss both the methods in detail. Before starting, let us see the types of quadratic inequalities. A quadratic inequality is one that can be written in one of the following standard forms. It can be less than 0, less than or equal to 0, greater than 0 and greater than or equal to 0. Hope you are familiar with the standard form of the quadratic equation. A x square plus bx plus c. That would be equal to inequalities. For inequalities, these are the four different cases. A quadratic inequality is in standard form when the inequality is set to 0, just like a quadratic equation. And the degree of the polynomial expression is always 2. Okay. Now let us start with the first method, solving quadratic inequalities using a sign graph of the factors. This method of solving quadratic inequalities only works if the quadratic factors. If it doesn't factor, then you will need to use the test point method, the second method we will be discussing after completing this method. Okay, first let me explain you the steps and then we will take suitable examples and look at this sign graph of factors method. Let me first list out the steps. Step 1 is write the quadratic inequality in standard form. This is a very important step. So that you have to write one side of the inequality equal to 0. Whatever inequality you are getting, you have to rewrite that as equal to 0. 0 is just like a magic number. It is the only number that separates the negatives from the positives. For example, if an expression is greater than 0, then there is no doubt that it is a positive sign. Am I right? Greater than 0 means a positive one. Likewise, what will happen if it is less than 0? Less than 0 means the sign is negative. So you cannot say this about any other number. You can take any number, but we cannot make sure of the sign. That is the speciality of 0. Since we were working with inequalities, this idea will come in handy for you. So with this technique, we will be looking at the sign of the number just to determine if it is a solution or not. Hope you're clear with step 1? Okay, now step 2. Solve the quadratic equation ax square plus bx plus c equal to 0. In step 1, we have set up equal to 0 and now we are going to solve for this quadratic equation by factoring to get the boundary points. The boundary points will mark off where the quadratic equation, the expression is equal to 0. So this is like the crossover point. 0 is neither positive or negative. Okay. And as mentioned, this method of solving quadratic inequalities only works if the quadratic factors. If it does not factors, then we have to choose the second method, that is the test point method. Okay. Now step 3. Use the boundary points that we got in the previous step to mark off the intervals on the number line. That will help us to draw the marks on the number line and list all the factors that we got in the previous step. The boundary points on the number will create test intervals. Okay. Now step 4. Find the sign of every factor in that every interval. So we have divided in step 3 and you have to pick any number and check the sign of every factor in every interval. You will understand this step while we solve the example. You can choose any value in an interval to plug into each factor. Whatever the sign of the factor is, with that value gives you the sign you need for that factor in that interval. So please make sure that you find the sign of every factor in every interval. Since the inequality will be equal to 0, we are not interested in the actual value that we get when we plug in our test points. But what the sign that we get matters, whether it is a positive or a negative. So this important step will be very easy for you. It is just like picking some number, plugging in the equation and finding the sign. Okay. Now next step. Step 5 would be using the signs that we got in the previous step, we will be determining the sign of overall quadratic function in each interval. Since the inequality will be set equal to 0, we are not interested in the actual value that we get when we plug in our test points. But what the sign is matters. So when you look at the signs of your factors in each of the intervals, please keep in mind that they represent product of the factors that make up your overall quadratic function. You have to determine the sign of the overall quadratic function by using basic multiplication signs rule. Hope you are familiar with those rules. The product of two factors that have the same sign is positive. Positive times positive is positive. Negative times negative is negative. Okay, I'm sorry, positive. The product of two factors that have the same sign is positive. And you know the very popular multiplication sign rule too. The product of two factors that have the opposite signs is negative. Am I right? Positive times negative or negative times positive will give you a negative answer. So if the quadratic expression is less than or equal to 0, then we are interested in the values that causes the quadratic expression to be negative. If the quadratic expression is greater than or equal to 0, then we are interested in the values that cause a quadratic expression to be positive. And next step is just writing the solution set and graphing. That would be the final step, step 6. So these are all the 6 important steps in solving quadratic inequalities. Now let me take one example and help you to solve that step by step, the same step we are going to follow. Okay, let me take one example. Here is an example. Here we are going to solve using a sign graph of factors, and we are supposed to write our answer in interval notation and graph the solution set. X square plus 2x minus 15 less than 0. So I'm going to show the solution step by step. The 6 steps we just discussed. After completing this example, you can get back to the 6 steps and have a review. Okay. Step 1. Write the quadratic inequality in standard form. It is already in the standard form, no? Ax square plus bx plus c. So you need not rearrange it. The quadratic inequality is already in standard form, so we are just not doing anything in step 1. And next step is solve the quadratic equation after setting this is equal to 0 by factoring. So we can get the boundary points. Okay, I'm going to rewrite this inequality as equal to sign. Now let's factor. We need to find two numbers that would yield negative 15 when multiplied and 2 when added. So what are the two numbers? 5 times negative 3 will give you negative 15, and if you add it, you'll get a positive 2. So you should find two numbers that would yield the last number, the constant, when multiplied, and that would yield the middle number when added. So this is how we factor any quadratic function. Am I right? Quadratic polynomial. Okay. Now let's factor the left side. Hope you're clear with this step. If the product of any factor is equal to 0, then we can equate each of the factor to 0 and solve for x. Hope you're familiar with that rule too. Okay. Now set the first factor equal to 0 and solve for x. And then set second factor equal to 0 and solve for x. From the first factor we got x is equal to negative 5. Now let's do the same thing for the second factor. So we have got two values, x is equal to negative 5 or x is equal to 3. So these are the two boundary points, negative 5 and 3 are the boundary points. Hope you're clear with the step? Okay, now third step. In third step, we are going to use these boundary points to mark off test intervals on the number line, and we are going to list all the factors that we got in step 2. Okay, let me draw the graph. On a number line, I have just marked negative 5 and 3. So in this graph that marks off the boundary points negative 5 and 3, and it shows 3 sections for those points have created on the graph. Am I right? So note that open holes were used on those 2 points since our original inequality did not include where it is equal to 0. We just have the symbol less than, no? So in case if it is a less than or equal to, then we would have included these points. Since it is just less than, we are not including. We are just drawing an open circle. Note that the two boundary points create 3 sections on the graph, starting from infinity, negative infinity to 5, negative 5, negative 5 to 3, and 3 to positive infinity. Am I right? So these are the 3 sections. Step 4 is to find the sign of every factor in every interval. So you can choose any point in an interval to represent that interval. Please remember that we are not interested in the actual value that we get, but what sign that we are going to get is matter. Okay, if we choose a number in the first interval is starting from negative infinity on the number line till negative 5. You can choose any point. I'm going to choose negative 6. You can choose any point and check the same. It would make the factors negative. Am I right? X plus 5. So I have chosen negative 6. Negative 6 plus 5 will give you negative 1. Okay, so I'm getting a negative number in this first interval. Now let me choose one number in the second interval. Second interval starts from negative 5 and 3. So 0 lies in between, no? So it is always better to choose 0 in case if it lies in the interval. So if I plug in 0 here, I'm getting, I could have used negative 4, negative 1 or 2 as long as it is in the interval. It would make x plus 5 positive and x minus 3 negative. Am I right? Okay. For this one, I'm getting negative and negative for both in first interval. And same way for this one, I'm getting positive and negative. Okay. Let me choose one number in the third interval, 3 to infinity, like 4. Okay. So it would make, if I plug in 4 here, I'll get a positive number, 4 here, I'll get a positive number. So it would make both the factors positive. Am I right? Okay, let me write the signs here. I have mentioned the signs for x plus 5 and x minus 5 in each of the interval section. So using the signs that we got in this step, we are going to determine the sign of the overall quadratic function in each interval. So in the first interval, we have negative times negative. So the sign of the quadratic in this interval is going to be positive. In second interval, we have positive times negative. So the sign of the quadratic in this interval is going to be negative. And in third interval, positive times positive. So the sign of the quadratic in this interval is going to be positive. Please keep in mind that our original problem is x square plus 2x minus 15 less than 0. Since we are looking for a quadratic expression to be less than 0, that means we need a sign to be negative. Less than 0 means we need a sign to be negative. Am I right? Okay. So it looks like the only interval that is quadratic is negative in the second interval. Am I right? Negative 5 to 3. So let's write the solution set and graph this interval notation. I have used this parenthesis here, open interval, indicating all values between negative 5 and 3. I didn't use this parenthesis. It means it includes the value. So let me graph this negative 5, 3. That's it for this example. You can view this example once again and look at the steps that we initially discussed. In case if you get any query regarding the steps, you can let me know. I shall be glad to answer any question regarding solving quadratic inequalities. Thanks for watching. See you in the next video.